Hello, everyone. Thank you for joining me. Today, I'm going to walk you through the machine learning problem that I solved in Kaggle, one of the recent competitions that I participated in. It was to predict the academic data where we had data on dropouts, enrolled, and graduates. So, this is a problem where we need to come up with a machine learning algorithm which predicts the dropout candidates so that the university or the educational institute can take some active interventions and reduce the dropout rate. So it's really a very practical, real life example. So it was very interesting to find out what the analysis was telling us, and then, of course, come up with the machine learning algorithm. So, how I approached this problem is to dive into the data, find out what are the data points telling us, and then, based on the number of variables and the complexity of the data that we have, I have used a very simple tried and tested random forest, and I think it is giving us a good accuracy. So, that is why, as we discuss further on the algorithm, you'll only see that I have used just one algorithm. So, my idea to do this competition was to approach this problem from a more data analytics perspective and try to come up with recommendations rather than just focus on the machine learning algorithm. So, I hope you find this interesting. So, let us get started. So, first and foremost, as you can see that I have loaded the libraries that I would need. Then I have loaded the training data set. So because this is an active competition, so we have the training data set, the test data set, and also a submission of which we would need to update and submit for the competition. So uh, initially, I'm just looking at the training data set and trying to create a model using this training data set and see how the model works in terms of overall accuracy. So first, we are loading the data set and trying to see the various columns here. And it looks like the last column, which is the target, is actually telling us whether the candidate was a graduate, dropout, or enrolled. So, about 38 columns we have. So, now just looking into the information, how many null values and what are the data types. So, the data set is pretty clean. So, we don't need to do much in terms of data manipulation. That is good. Now, this code is checking the null values. There are no null values. So, life is simple for us now. Let us look at the data types. So, there's numerical values. A lot of them are numerical values, but it's actually not numerical. So, if you see the course would be a categorical data, right? It would not be a numerical data, but the way it is stored, it is an integer variable. So also marital status is stored as an integer, but we know that marital status is not an integer, it's a categorical data. So these are the things that we need to take into account as we go further and analyze the data. So from this code, I have just divided the categorical data and the numerical columns. But as you can see, as I explained earlier, this does not work for us because we have to manually separate the categorical columns and numerical columns based on our understanding and intuition. So this is how what I have done is I have separated them in a list, and then now I have separately analyzed categorical columns, and this is to see what are the unique values in each of these columns. So for marital status, we have 1, 2, 4, 3, 5, 6, and we don't have what exactly these values are because for data privacy, we don't we have not been shared what exactly 1 means, 2 means, 4 means. So we don't know what exactly they are. Now let us look at the value counts for each of them. So for each and every value in that particular column, we have the counts as well. So we can see what's the relative frequency for each and every value. Everything makes sense here. So this exercise I basically do to understand, does it make, you know, some good sense to club the data or not. But on the surface of it appears that the data set is good for categorical. There's also bar chart representation that I have done just to look the counts for each and every values from a visual perspective. So this is very interesting. Let me zoom in. If you see the relative frequencies, um, the count of dropout is in the middle of the graduate and the enrolled. So we have good data to analyze. It's not that it's skewed for one data point. So I've also done a quick value counts and normalize the data to see what is the percentage. So the percentage of dropouts in data is about 1/3 of the total data points. That is good. And these are some of the observations that I have written based on the looking at the categorical charts, is that most of the students are married, and the application mode 1 is most common, which is one of the most popular course. Some of the students are enrolled in evening sessions, so looks like they might be working, and they're also enrolled in some courses. Then there are students who would have a special assistance requirement, so that is good for the institute. There are some students who have taken debt to study for the course. There are students who have fees overdues, and so yeah, we can see from this chart, right? I don't know which chart it is, but you can see this debtor count of debtor. There are some students who have taken loans. There are some international students. There are a handful of students where the tuition fee is not up to date. Scholarship holder, there are meritorious students in the uh, institution. There are students who are needing some special needs. There are some displaced candidates, and I'm not sure what exactly this means, but the data set looks balanced for this category. Nationality looks like most of the students are from one nationality. Daytime and evening time, as I said, that there are some students who are doing evening classes. So, we just get some idea based on looking at the categorical data, that overall what trend we see. So now let us look at the numerical columns, and for numerical columns I have done a box plot just to see the outliers, and also I have separated the, each and every category of target column to see if there is a difference, if there is a major difference between any of these numerical columns. And the way we read it is looking at the median values. So there are certain instances, like for the dropout target, the median age is higher. So it looks like people who are a bit older and they are enrolling in the courses, they are dropping out. So also for admission grade, for the dropout candidates and also for the enrolled candidates, it is almost the median value for admission grade is same. So this does not add much to the interpretation, but we do get an insight that where these scores are showing a huge deviation. So for example, if we see these are scores, curricular units second semester approved. Here the median values of dropouts is very similarly for some other plots also. So it's more or less, we are trying to see the box plots, but not much comes out of these box plots. I've also drawn some histograms to see, but from numerical columns, we don't get much. And I've written this like for age, it is very obvious as we saw in the box plots. Then there are other variables like curricular units for the first, second, third semesters and grade. The median values are slightly lower for the dropout candidates. And for other factors like unemployment rate, inflation rate, and GDP, the factors don't seem to differentiate between the three categories. So that was all about the categorical and the numerical. Now, when we look at, so now we are almost ready to do the machine learning, apply the machine learning, and pretty simple steps. First is we use the label encoder to transform our target column into the binary form 0, 1, 2. And you can see after applying the label encoder, we have this new column named as target encoded. And the output here is like 2, 0, and 1. So if you can read, like graduate means 2, dropout means 0, and enroll means 1. So we have to make the data set in a format that the machine learning can use it. And for machine learning to use it, all the values should be numerical columns. So we'll drop the target and ID. These are some of the columns which we do not need. And then here we are isolating the x and y variables. And then using the train test split. Then finally applying the machine learning random forest here. And the overall accuracy is about 83%. So the model looks good, and as the model looks good, I'll now apply this random forest machine learning in the entire data set and use that model to train in the test data set. But before that, I've also used feature importance to get the top 10 features that are important. And this is very important to note, especially when we are trying to explain to stakeholders like what are the top 10 features. So mostly these are the columns which are important, like curricular units, second semester, grade, what was approved, evaluations. And also you can see that admission grade, previous qualifications, age, tuition fees are also some of the factors that influence the dropout. So it's not just the current academic performance that makes or ensures that the candidate or the student will be a graduate, but there are other factors also, like the age, the tuition fees, the previous qualifications, the admission grade, also determine whether they will drop out or not. So there's a quick conclusion that I have written here, and you can also read that if you happen to be in my Kaggle page. Pretty good insights and summary. And this is now a quick submission where I have used the submission file and then I have applied the transformations and submitted the file for the analysis. So quite some steps to get to the submission file, but that was all it in the analysis. I hope you liked it, and thank you, and I'll see you in my next video. Thank you.